Imagine the southern Gold Coast. This is a landscape defined by perfect surf breaks and long, continuous stretches of white sand. But a few decades ago, this iconic shoreline reached a crisis point. Its famous beaches were rapidly and violently vanishing. This photograph shows the scale of the damage. You can see the sheer drop of the sand cliff, with two people standing near the edge for scale. Storm waves had aggressively stripped the sediment away, leaving behind dangerous, unstable cliffs. This destruction followed the unintended domino effect of a human engineering project built just a few kilometers down the coast. To understand what went wrong, we have to look at how a beach actually works. It isn't a static landform, it's a dynamic, moving system. Here is the biophysical process called longshore drift. Waves strike the coast at an angle, transporting sand parallel to the shore. This river of sand acts as an automatic repair mechanism. When storms gouge the coastline, the current refills the beach with sediment. The survival of any beach ecosystem depends entirely on this uninterrupted flow of sediment. If you block the river of sand, the system breaks. South of those eroding beaches sits the Tweed River. By the mid-20th century, navigating this river mouth was notoriously dangerous. A shifting sandbar routinely caused fatal shipwrecks. To protect boat traffic, local governments in the 1960s built massive concrete and stone training walls straight out into the ocean. The walls successfully shielded the boats, but this aerial survey shows the unintended consequence. The physical protrusion of the walls acted as a dam, entirely blocking the natural longshore drift moving up the coast. Starved of their replenishing sand supply, the northern beaches could no longer recover from these violent storm events. They rapidly eroded under the pressure of normal wave action. Without a protective sand buffer, the ocean crept closer to human development. As you can see, waves began directly undermining these beachfront apartment buildings, putting entire blocks of urban infrastructure at risk. By forcing nature to comply with a local economic need, engineers had accidentally broken a massive ecological cycle, a mistake that required a systemic solution. The governments of New South Wales and Queensland launched the Tweed sand bypassing project. Initially, they relied on brute force dredging to manually pump more than 3 million cubic meters of sand back onto the beaches, but manual dredging is only a temporary fix. In 2001, a permanent system was installed, infrastructure designed to mimic the broken forces of nature. This map shows the bypassing mechanics. The sand collection jetty physically traps blocked sediment on Letitia Spit. It's pumped through subterranean pipelines directly underneath the Tweed River channel. Finally, sand is discharged at Snapper Rocks and Kira, re-entering natural ocean currents. The system requires immense mechanical force to physically expel this heavy sand-water slurry back into the coastal surf. This system functions as a mechanical pacemaker, bypassing the training walls to artificially complete a biophysical process that was once broken. This aerial view from 2020 shows the project's success. It provides proof of both wide, nourished beaches to the north and a safe, clear navigation entrance for the river. The restoration has returned world-class surfing breaks to the coast, supported a multi-million-dollar tourism industry, and rebuilt the critical sand buffer that protects waterfront homes from storm surges. However, this balance is fragile. The system requires constant data monitoring to ensure it matches the natural quantities of sand movement without overcorrecting. We can see a shift in management strategy here. The 1960s approach tried to fight the ocean with concrete. The modern approach uses engineering to accommodate natural systems. True sustainability isn't achieved by building over nature, but by ensuring our human footprint is designed to seamlessly integrate with Earth's interconnected cycles.